In this section, we will discuss the concept of Anthropocene. This concept will help us to understand the challenges, environmental challenges that we face today, that are completely different as in the past, as we have discussed before. The Anthropocene is a term that has been used to reference the fact that humans have become such a dominant force in the world that many scientists consider this to be a new geologic epoch. Anthro refers to humans, and that is why we call it Anthropocene. To understand this concept, we're going to define how the Earth's history is separated into different time scales. The Encyclopedia of Global Environmental Change lists key external forces which can alter the Earth system as the Sun and its output, the rate of Earth rotation, Sun-Earth geometry and the changing orbit of Earth around the Sun, and the Earth's physical makeups such as distribution of land and ocean. Now a new force has been added to the list, which is humanity. And scientists believe that humanity is now the main driver of change. To start understanding the Anthropocene, we're going to define how the other geologic time scales look like. So these are average temperatures over the past 500 million years. As you can see, there were significant variations of temperature in the past, even plus minus 14 degrees Celsius, as compared to the current temperatures. During those periods, life on Earth was completely different. Then there was the appearance of the Homo sapiens in the Pleistocene. Then we had a period, which is called the Holocene, that began around 10,000 years ago and saw the beginning of agriculture and those permanent human settlements. To argue that we're living in a new era, we need to define how the Holocene looked like and why the Holocene allowed the conditions for human civilizations. So in this figure, what I'm showing you is the most recent 70 million years on the top figure. And then we also have the most recent 3 million years encompassing the Quaternary period. Then we have the most recent 60,000 years of Earth history, showing the transition from the most recent Ice Age into the much more stable Holocene, which was about 12,000 to 10,000 years ago. And then on the bottom, we have the most recent 16,000 years of Earth history, showing the Holocene and the transition into it from the most recent Ice Age. So what the first figure can tell us is that humans have been in existence for only a very small fraction of the Earth's history, and that the planet has evolved in the very different ways, and the conditions are completely different as the conditions that we have today, right? And then what is also interesting is to see the second figure, because we can clearly see the Quaternary period, and this clearly shows long-term climate variability. So you can see that the range in variations is very, very high, and even on the last 100,000 years, right? So this is seen as a transient phase of climate instability, and that was leading to a new stable or permanently stage. That was the period of glaciation. So one key thing to see on the figure is that the Holocene, in comparison to the Pleistocene, has shown remarkable stability in terms of climate, right? And that there has been the range in temperature change is only 1 degree Celsius, with some exceptions that we can see actually on the lower figure, where we can see some periods that were the warmer or were colder, right? So these are marked as the medieval warm period and a little ice age. So this stability has been maintained for longer than in the last 3 interglaciers and might naturally continue for at least 20,000 years. And what is a good thing about the Holocene is that it has allowed to have settlements, and it has allowed to have the development of the agriculture. and also in general the development of the civilization. So we could argue that we can actually live on on a harsher environment as the ones that were present before the Holocene, but our life will be very different, right? Other aspects of the Holocene environment is that the behavior of some nutrient cycles, such as the nitrogen cycle, or the amount of atmospheric aerosols, and also the changes in ocean circulation. These changes allow the development of the ecosystems that we know now, and also the development of the biodiversity that we currently have, and that we need for our subsistence. So now that we have established what is the Holocene period, or what were the main characteristics of the Holocene period, now I'm going to show you how different it looks in terms of temperature and carbon dioxide concentrations in the atmosphere, with the epoch that is called Anthropocene. This new geological epoch was named to acknowledge human influence on the state of the planet. The state of the planet in the Anthropocene is not yet determined, but a current trend in human activity predicts that it may be much hotter than the Holocene period. So on the figures that are on the right side, what I'm showing you is a comparison between the Pleistocene, the Holocene, and the little that we have of the Anthropocene. So you can see on the first figure the CO2 concentration, and as I mentioned to you before, during the Pleistocene there were lower concentrations of CO2, but they started building up until the concentrations that we had during the Holocene. And then you can see the huge increase of CO2 concentrations during the Anthropocene that currently are around 450 ppm. As you can see on the temperature on the second figure, this is temperature anomaly, and in this figure we can see that the CO2 concentrations from the first figure correlate with the temperature anomalies, right? And you can also see that we also have a period during the Anthropocene, we have a huge range in temperature of anomalies, right? As compared to the other periods. We haven't seen any significant difference on the sea level, but then since all these three parameters were correlated in the past, we can also expect a big difference on sea level that will be the result of the increase in the CO2 concentrations. So now the question arises: have we entered a new phase of planetary history? By definition, the beginning of any new epoch must be marked by globally dispersed signal found in rock layers and deposits. There is substantial evidence already that we have in rocks the signals of human activity, like we have radionuclides from the nuclear testing, onboard carbon spheres from power stations, plastic pollution, aluminum, concrete particles, and residue from fertilizers. So it means that we can have the tick box for defining a new epoch to the evidence on the rock layers. But as it was mentioned before, there are external factors which could change the state of the planet that are beyond human control. For example, the output of the sun or the shape of Earth's orbit around the sun. We will discuss this later, but what we know now is that these changes are believed that may not change the Holocene state for at least several thousands of, even tens of thousands of years. And this estimation is based on scientific understanding of the solar cycles and patterns of change of Earth's orbit. So even if it's not clear when exactly the Anthropocene started, we now need to know what will be the end state of the planet. It is clear that the state of the planet is no longer a Holocene-like state. So we have left the Holocene epoch, but the state of the Anthropocene is still to be determined. We are at the tipping point. The tipping point is the point where there is no going back into the Holocene epoch, and we are looking to the future. We have three options, potential options that can occur. We can live on a stable Holocene-like state, or we can have a slightly warmer, slightly less stable state, or we can have a very warm, highly unstable state. The future of the planet will be determined based on our actions. But we can already say that only with 1 degree of increase in temperature, we have seen many consequences or actions that have affected our livelihoods and also our economy. We've entered the globalized phase of environmental change, and now everything is connected. So in real time, if someone goes to work emitting carbon dioxide in one part of the world, it has in real time effects on livelihoods of other individuals in other parts of the world. These global connections also have economic and social consequences. One example is the Arab Spring, which was an enormous rising of educated people and connected people that was rising against a dictatorial rule over many decades. And this was also connected to the increase and volatility of food prices and also food riots that were arising from climate change. And this was also even combined with the lack of fertilizers, lack of phosphorus, and oil prices that were rising too. Another example is the droughts that occur in Australia that were connected to the increase in food prices all over the world, and even also connected to policies that were implemented around the world. So in conclusion, humanity is now the driver of change, and therefore we're in the driving seat, and we can actually make a choice. Either we continue on a unstable path, or we move to the transition on a sustainable pathway that can lead us to a Holocene-like state that can manage humanity for the coming years.